I'd like to talk about linear functions today. This is 3.3 to discuss what it really is. First of all, the word linear means straight lines, right? So linear function is an equation essentially representing a straight line. So let's talk about the first vocab word that I want to discuss today is linear equation. It has a specific format to it, but the basic idea is it is an equation of a straight line. Okay, it has several formats, and I'm going to introduce to you the first format. We call it the standard form of a linear function. The standard forms look like the following. Okay, these ABCs are all numbers. With the idea of a linear equation in standard form, let me remind you what a standard form looks like. Don't forget, here's your coefficient x plus b coefficient y equals to c. And don't forget that a has to be bigger or equal to 0. It can't not be a negative. It's just a format. Please understand that when you start writing an equation like this, you don't start with a negative, and that both a and b can't both be 0. One of them can be 0, but not both. Okay, just kind of keep that in mind for you to write a standard form. Now, why is it so important? Because any equation that can be written back into this form will be a linear function. Okay, because your homework will obviously ultimately ask you to recognize if that is a function or not. But that's kind of give it away that if you can actually convert it back into this format, it is automatically a linear function. Well, if you recognize about this closely here, notice that both x and y, they both have a power of 1. So that's one giveaway. They both have power of 1, okay? And you can see that they're both are on top, okay? Not denominator, numerator. Okay, so two important concepts that you need to understand. So let's take a look at this example right here. Imagine I have y equals to 3 minus 1 over x, okay? Then you're going to ask yourself, well, can I somehow put this format back into this form, the standard form? Well, we know we want to have x and y on one side, so that means we need to move this whole thing over. So let's plus it over. Let's add it over. So it's going to be adding 1 over x, which means it's going to be 1 over x plus y equals to 3. And if you look at this now, y is on top, however, x is not. And you can't possibly put it back on top, okay, without, ensuring that it still looks like this. There's no way you're going to be able to do it. So therefore, this is nonlinear, not a linear function. Okay, so let's try another one right here. So let's say I have this. Okay, I hope by just looking at this, you see that this is not a linear function right away, just because right there, y square. You cannot have a power of 2. It has to be a power of 1. Okay, so because of that, square power. This is nonlinear again. Okay, so let's try something that actually works here. Pretend that I have the following. Okay, so I want to put this back into a standard form, which I can. I know I want all of the x and y to one side, so I'm going to take that and move it over by performing the opposite operation, which will give me 5x minus 7y equals to -2. And it looks like what I have. So therefore, because I can actually convert it back into a standard form, this is automatically a linear function. Okay. Sometimes it doesn't look exactly the same. However, let me demonstrate that case right here. Pretend I have this. Okay, so let's say I have something like this. Okay, so we want to move all the x's to one side, so I'm going to take this and move it over. You got negative 5y equals to 7. Now you're probably going to ask yourself, wait, it doesn't look anything like this. Then how's that a linear function? By the way, let's kind of understand this here. Even though it doesn't look anything like this, but don't forget, a can be 0, right? It can't both be 0, but a can be 0. So technically, you can write it like this. Here's 0x minus 5y equals 7. So now it does look like that. Okay? I got my a and b coefficient. I got my x and y on one side. I got my number on the other side. So even though it's not there, it still is a linear. Okay? Just kind of keep that in mind. That sometimes it doesn't look exactly the same. However, certain cases it will be a linear equation. Okay, so let's practice on that, and let's see if I should give you another example. Yeah, sure, why not? And by the way, if you solve this completely, like this, for example, this is negative 5y equal to 7 divided by negative 5. Y is certainly going to be a negative 7/5. You can graph this if you want at this point, but we're just going to leave it like that. And yes, it is a linear function because when you graph this, it is a horizontal line, which will pass a vertical line test. So let's take a look at this next one. Pretend I have, let's see, let me give you a good example here. Okay, so let's try this one. Okay, so same question again. Is this a linear equation? Well, let's see. Well, you want to write in this format. Even though you have your x and y on one side, however, if you compare it term by term, this one has the y, the coefficient's there. This one has an extra y. So therefore, because of that extra y, it's automatically a nonlinear. Okay, it has to look like that. It's either this term is gone completely, or it can't be can't having an extra y or an extra x. Just kind of keep that in mind there.